In this video, we're going to take a look at the three calculations, or the three most common calculations that we need to do when we're dealing with solutions. And so again, this is not a pure substance, it's a homogeneous mixture, and it's this idea of having a small amount of solute, for example, salt, dissolved in a large amount of solvent, for example, water. Here I have a drawing, you can see the ratio difference. Now the first calculation that is very important in terms of solutions is figuring out the amount of something needed to prepare a solution. So the amount of whatever substance you're dissolving needed to prepare a solution of that substance. So for example, if we want to make a 1.5 molar, that big M stands for molar, or mole per decimeter cubed, same thing, solution of NaOH, of sodium hydroxide, and you need to make 25 centimeters cubed of it. How many moles, how many grams do I need? So the main formula in terms of solutions is this idea that concentration of a substance is equal to the number of moles of that substance divided by the volume, and that'll give you the concentration. So again, here, because our concentration is in different units than our volume, we need to change centimeter cubed to decimeter cubed, and here we need to divide by 1,000. You need to remember that. That's very common. The IB loves to give volumes in centimeters cubed and concentrations in decimeters cubed. So here I'm putting in the numbers that I know, solving for moles of NaOH, and I get about 0.038 moles, and again I can very easily convert that into grams by multiplying by molar mass of NaOH, and that's it. The second very common calculation that you will need to be able to do with solutions is converting between the two most commonly used concentration units. So again, we have moles per decimeter cubed, which can be also symbolized using capital M for molar. So a 1 molar solution of sodium hydroxide, we might be asked to find the percentage by weight of sodium hydroxide in water. How do we do that? Well, the formula here is we need to find the mass of the solute, so of NaOH in this case, and divide it by the mass of the solvent, in this case H2O, multiply that by 100. So again, what I have to do is I need to find both of these masses, and then I can do the calculation. So what I'm going to do is I'm going to do the first calculation where I figure out the mass of NaOH. So again, this is going back to our mole conversion. I know that in my solution of 1 decimeter cubed, I have 1 mole. And if I know that 1 mole and I know the molar mass from the periodic table, I can easily find the mass of sodium hydroxide in this solution, which just so happens to be 40 grams. Then I can find the mass of water, and here I'm using density. Again, remembering that the density of water is 1 gram per centimeter cubed. And then I also remember that I have 1 decimeter cubed, which is, remember you have to convert so that your units agree with each other. 1 decimeter cubed is 1,000 centimeter cubes. So multiply decimeter cubed by 1,000 to get centimeters cubed. So overall, I have 1,000 grams of H2O. So what I'm going to do is I'm going to take both of those masses, put them back into the equation that I have up at the top, and so I'll get 40.0 divided by 1,000 grams, and then I need to multiply whatever I get by 100% to get percentage. So I would get 0.4 if I was doing decimals, but again we want percentage, so we're going to get that the 1 molar solution of NaOH is 40% weight of NaOH by weight of water. So the third calculation that you'll need to be able to be quite familiar with is this idea of diluting solutions. So a lot of the time in a lab we have very concentrated solutions of our solutes, and in order to perform an experiment we need to dilute those very concentrated solutions to get us to a concentration that is either safer or that we are looking for specifically for our experiment. In this example, I have a 10 molar solution. I have 1 liter of it, and what I'm trying to get to is I'm trying to dilute some of that solution to make a 1 molar solution, 1 liter of it. So in order to do this conversion and try to figure out how much of that concentrated solution I need to add, what I need to do first is I need to calculate the number of moles in the final solution. So using my concentration formula, rearranging for moles, I get that the number of moles is equal to concentration times volume. In this case, it's 1 mole per decimeter cubed multiplied by 1 decimeter cubed, which gives us 1 mole. So overall, we have 1 mole in our final solution. The next step is to realize that the amount of moles we need to transfer is the amount of moles that is in our final solution. So the amount of moles that we need to transfer from our initial solution is the amount of moles that's in our final. And so using that number and using the initial concentration, the more concentrated concentration, we can figure out how much of that very concentrated solution I need to add. Again, I've rearranged the concentration equation. Now I'm solving for volume. And so again, the volume that I need to take from my initial solution would be the number of moles divided by the concentration. And again, here we've already determined that's 1 moles, and we have a 10 molar solution. So overall, we need to add 0.1 decimeters cubed, or 100 centimeters cubed. Remember, converting between those is a factor of 1,000. So here I'm just going to draw that out so you can picture it. So I'm going to be taking 100 centimeters cubed from my initial more concentrated solution. I'm going to put it into an empty flask. And then what I'm going to do is I'm going to add water to that concentrated solution until the volume of my solution reaches 1 decimeter cubed.